Hey, if we look here, we have another way to solve quadratic equations. You have quite a few ways um, in your math toolbox there to solve quadratic equations. This one's going to be by the quadratic formula. And once you hear formula, you should be thinking that you should have some sort of formula memorized. It's helpful to have it memorized. So if you look here, the quadratic formula is based off of the quadratic equation ax squared plus bx plus c is equal to 0, and this is where we get a, b, and c from, or from these coefficients. And the quadratic formula works as long as a does not equal 0, because if a equals 0, what's on the bottom of the fraction? You got it. 0 would be down there, and you're not allowed having that. So here's the quadratic formula. You're going to use this for every single problem, and you might want to write it down, keep it handy, and every problem I'll be saying it out loud. I won't necessarily be writing it down the way you see it there. So let's look at an example. If we solve this equation here, and the quadratic formula says it has to say equal to 0, this doesn't say equal to 0, so let's go ahead and change it so it does say equal to 0. Subtract 4x from both sides and add 13 to both sides. Now it equals 0. Let's check to see if we can do quadratic. I can see if we can factor it. We take a times c to get 13. So those are the numbers that multiply to get 13. Do those numbers add up to give you -4? No, they don't. So we cannot use factoring here, but we can use a quadratic formula. We could also use completing the square, but that's in a different video. We're going to do quadratic formula here. Quadratic formula says x is equal to negative b. In this case, b is in front of x. Well, if we say -4, and you know what, it might be helpful to label what a is equal to, what b is equal to, and what c is equal to. In this case, a is 1, b is -4, and c is 13. Make sure you pay attention that I did not put any x's with those coefficients. All I want is the coefficients, the numbers in front of the variables. All right, quadratic formula says negative b, so I plugged in -4 there. We do need this negative sign out front because that's part of the formula. All right, plus or minus, and then we're going to say square root of b squared, so that's -4 squared, minus 4 times a times c. That is over 2 times a. That should be easy enough, right? And let's go from here. If we have -4, that should be a +4. -4 squared, a -4 times -4 should be 16. And 4 times 1 is 4, and then 4 times 13 should be 52. And this minus sign comes down. On the bottom, 2 times 1 is 2. What do we have underneath the radical when we subtract? 16 minus 52, I believe, is 36, -36. Over top of 2. And let's simplify. We can simplify that radical. X is equal to 4 plus or minus. Let me get some working room here. That's not much working room. Watch this. This is magic. Ah, working room. Just appears like that. Here we go, working room. Okay, so now we're going to have the square root of 36 times the square root of -1. What's the square root of 36? You got it. And what's the square root of -1? I. So there we go. We're going to take that 6i and put it there. Divide everything by 2. And when we do this, we should be thinking it's 4 over 2 plus or minus 6i over 2. And this will let us reduce. 4 over 2 is 2. And 6 over 2 is 3. And so there we go. There's your two, in this case, they're imaginary. Your two imaginary roots. Your two imaginary solutions. 2 plus or minus 3i. We are going to come back here. There's a special term for this number underneath the radical, and that's the b squared minus 4ac part. We're going to come back there, but I want to go ahead and leave that on there. We're going to come back there at the very end, and I'm going to show you a few things about that number. Looking here, solving. Once again, we're supposed to set everything equal to 0, so if we subtract 5x here and we add 9, okay, that's going to leave us with x squared minus 6x plus 9 is equal to, remember we subtracted 5x and we added 9 before. Yep. This one is going to factor for us. Although I will go through the quadratic formula with you, but I would, if I was solving this, I would just factor. Two numbers that multiply to give you 9, and that would be 3, 3, or negative 3, negative 3. And those two numbers are supposed to add up to give you negative 6, and in that case, that's negative 3, negative 3. Just watch this part right here. Essentially what you should be doing to get this done if you are working on a time crunch, factoring it like this. And you know x minus 3 equals 0 here, and here, x minus 3 equals 0. So therefore, x equals 3 here, x equals 3 here. Well, we know what the answer is because we could factor it. And we'll show you the quadratic formula, and let's make sure it matches. Quadratic formula works all the time. This one was pretty easy if you factored it. Quadratic formula would have had some steps to it, which, I mean, it still would have been pretty easy. Let's go ahead and label this. A is equal to the number in front of x squared, 1. B is equal to the number in front of x, which is negative 6. And C is equal to the number without a variable, 9. So x is equal to negative b. Well, in this case, b is negative 6. What's negative negative 6? Positive 6. Let's go plus or minus b squared. Well, negative 6 squared is going to be 36 minus 4 times a times c. And on bottom, 2 times a, 2 times 1 is 2. So let's go ahead and simplify under the radical. 4 times 1 is 4, times 9 is 36. So this is really 36 here. What is 36 minus 36? 0. And then so therefore, the square root of 0 is 0, and all we're left with is 6 over 2, which is 3. And that's the same solution we got from factoring. I ran through the quadratic formula so that way you had another example here. This number here, remember we're coming back to this number. Remember that that was the b squared minus 4ac. b squared minus 4ac was that number underneath the radical. We're going to come back there. At the very end, I need to show you a few things. We're going to skip this one. Let's go ahead and try this one here. Let's see if you can do this one on your own, and then check your solution with mine. All right, so I know that x squared plus 5x plus 2 is equal to 0. A, B, and C are equal to 1, 5, and 2. So 1, 5, and 2. X is equal to negative b plus or minus b squared. 5 squared is 25. And then we're going to say minus 4 times A. 4 times 1 is 4 times C, which is 8. Over top of 2A, which is 2. Negative 5 plus or minus the square root of 17 over top of 2. And there you go. There's your solution, your two solutions there. If you wanted decimal approximations, you would approximate the square root of 17 to some number. It's 4 point something. Let me see if I have it right here. I do not have it right here. But if you were supposed to do a decimal approximation, then you would just change that to 4 point something divided by 2. One of your answers would say plus, and then your other answer would say minus. Okay, so here's solution number 1, solution number 2. Now you could also see it up here, that you would have two solutions. And back to this number right here, 17. Remember that number is the b squared minus 4 times a times c. Okay. All right, this last slide here has a little bit of an explanation, so pay attention to my explanation first, and if you need to write it down, this is something that you should know. So at the end of every problem, I was circling the number underneath the radical because it's called the discriminant. It's called the discriminant. That is the b squared minus 4ac part. The b squared minus 4ac part. So if the discriminant is greater than 0, something occurs. If it's equal to 0, something occurs. And if it's less than 0, something occurs. So let's go back to our examples and look here. The last example, what was the discriminant? The discriminant right here was 17. 17. So 17 is, I believe 17 is greater than 0. Is that correct? Yeah, that is correct. So if we look here at 17, how many answers did we have? How many real answers? Well, there were 2 real answers right there. 2 real solutions when the discriminant is greater than 0. When the discriminant is greater than 0. A real quick graph of that. Discriminant is greater than 0. Parabola crosses once, twice. 2 real solutions. 2 real solutions. All right, now let's go back. Let's find one whether equal to 0 or less than 0. How about this one? This one was equal to 0, right? It was equal to 0. How many solutions? Looks like a 3. Equal to 0. 3 was equal to 0. How many real solutions? Well, there was 1 real solution. 1 real solution there. And that graph would look something similar to this. The parabola comes down and touches once. It sits on the x-axis there, and that is your 1 real solution. And how about when the discriminant is less than 0, that b squared minus 4ac is less than 0? What was it in this case? Right here it is. Over here on the right. Negative 36. It is less than 0 there. How many solutions did we have? Well, plus or minus means that we're going to have 2 solutions, but are they real solutions? That I indicates that this is an imaginary number. It's a complex number there. So, if we're looking here, what do we have? We had negative 36 for the discriminant, which was less than 0. So that meant that there were no real solutions. And it also meant that there were 2 imaginary solutions. You should also recognize that solutions are also talking about, another term for solutions in this case are zeros, and another term for solutions are roots. Just kind of depends on what it's equal to. So no real solutions when the discriminant is less than 0, but there are two imaginary solutions when the discriminant is equal to 0. And what that means is, if you're looking at this graph, the parabola just kind of sits above the x-axis. It does not cross the x-axis. So that's the discriminant, and that's how it's useful. Once you figure out what that discriminant is, you should recognize how many solutions there are. Well, I'm going to recognize that that's the end of this video lesson, and I will see you next time. Hope you have a good day.